Welcome to this video series on the topic of expansion and empowerment, Chapter A, Single Brackets. In this lesson, you'll learn how to expand expressions containing single brackets. Single brackets are a way of representing the multiplication of an expression. So we have the expression BC multiplied with A. Single brackets may be expanded by multiplying the inner terms by the outer coefficient. What that means is our inner terms B and C are going to be multiplied with the outer coefficient A. This will be done by taking the outer coefficient A and multiplying each inner term. We can represent this with the arrows as shown. Now, as a consequence of this, what will happen is we have A and it's going to multiply with B plus A multiplying with C. So this is the rule we're going to use when we expand single brackets. Let's have a look at how we can put it to purpose. Example 1. Expand the following expressions. We have, for the first example, 3 multiplied by the expression x plus 2. The way in which we expand this outwards is we have to identify our outward coefficient, so 3, and multiply it with each of the inner terms, so x and 2. Doing this, I'll start off with the arrows so I don't get lost, so I'll go 3 to the x and 3 to the 2. Next, I follow the arrows, it's 3 multiplied with the x plus the 3 multiplied with the 2. Multiplying this out, 3 times x is just 3x, and 3 times 2 is 6. And thus, we complete our first example of expanding single brackets. Next example, we have 5 multiplied with the expression y take 3x. Now this one's a little bit different because rather than a plus that we had over here, we've now got a minus. The way in which we deal with this is exactly like we did before. We go for our outer coefficient, 5 to the inner term y, and then 5 to the second term minus 3x. Next line down, that's going to look like 5 multiplied by y plus 5 multiplied by, and here's where it's different. We have minus 3x. The negative belongs to the 3, so I go minus 3x. Next line down to complete this, 5 times y is just 5y. And then next term across we have 5 and the minus 3. 5 3s are 15, 1's negative, so it's now minus 15x. Thus completing our second example and showcasing how we can expand simple single brackets. Let's look at some trickier stuff. Example 2. Expanding single brackets with negative and variable coefficients. So we're looking at our first example now with a variable in the outer coefficient, so this y, we've got 5y. How do we deal with this? Well, exactly like we did before. We go 5y multiplied by the expression y take 3, and then we're going to draw our arrows, so outer to inner, 5y to the y, 5y to the minus 3. Next line down, outer 5y, inner y, plus outer 5y, inner minus 3. Finishing this off, 5y times y is 5yy, but that looks messy, so what we'll do is we'll represent it using algebra, so 5y squared plus we have 5y times minus 3. 1's a negative, so that means that the final result is going to be negative, and it's 5 3's, so it's going to be minus 15y. Next example, we have minus 3x multiplied by the expression minus 5 plus 8x. Now again, this one looks a little bit tricky, but we can do it using the exact same process we've done in the earlier 3. The outer coefficient is minus 3x, and we take it to the minus 5, and then we take it to the 8x. Breaking this down, outer coefficient minus 3x to the minus 5, plus, and then we go minus 3x to the 8x. Now you might be wondering why there's a plus sign in front of the -3. We're allowed to do this because we're associating the minus with the 3, so it's -3 as opposed to subtract 3x. So this is still valid. Or if you want, you can get rid of it. Okay, next line down, we are going to go 3 5s are 15. Both of them are negative, so it's going to be a positive result. So that's 15x. And then we've got 3 8s are 24. One is negative, so it's -24. And then we've got x, and because there's two x's, we use the rules of algebra and we give it an index of 2. And thus we finish expanding our fourth example. Okay, let's go down for something even trickier. And by trickier, I don't mean it's actually harder, it just looks harder. So what we're going to do in example 3 is expanding single brackets with higher powers. So what does that mean? Well, we've got the negatives, we've got the variables, and now the variables are going to contain higher powers. So like to the power of 2, to the power of 3, to the power of whatever. Now the way in which we deal with these is, funny enough, exactly like we did in the previous two examples. We go for our outer coefficient, 2xy cubed, and then our inner term is, inner expression is x squared y take 3x to the 5. Next we draw our arrows so we don't get lost, and then we start expanding out. So this is going to go 2x y cubed in brackets x squared y, and then plus 2x y cubed multiplied by the -3x 5. Finishing this off, I'm going to go 2x. Now I'll arrange these in order just for now. So 2x x squared, then y cubed y, and then using the rules of algebra, the x times the x squared is going to be x cubed, and then the y cubed y is going to be y to the 4. So that's our first term. Next term, you can see there's a 2 and a 3, that's going to be 6, but one's negative, so it's -6. Then you've got x to the 5, y to the 3. Because there's two types of x's, it becomes x to the 6, y to the 3, or y cubed. And thus we complete part A of example 3. So you use the exact same method before, except this time we're just dealing with powers, so we're using our rules around algebra. Finishing this off with example B, we're one level of difficulty higher in that we've got the negative here now, but we deal with it all the same. So we've got -3a squared, which is our coefficient, and then our inner expression, first term is going to be -5ab cubed, plus second term is 8a to the 5b squared. Drawing in the arrows so I don't get lost. First term, second term, expanding this out, 3a squared -5ab cubed, plus, remembering that I can have that negative there with the plus, 3a squared multiplied by the 8a to the 5b to the squared. Expanding this out, 3 5s are 15, they're both negative, so it becomes positive. A squared times a is a cubed, and then it's b minus 3 8s are 24. A squared times a to the 5 is a to the 7, and then it's b to the 2, or b squared. Thus completing the final example in expanding single brackets. So in summary, what we set out to learn in this lesson was how we can expand outwards single bracket. So what we do is we multiply each inner term within the bracket with the outer coefficient.